Thanks everybody for tuning in to today's Arbitrum Dev Office Hours. I think we've done these. I know we did one prior, like I think last year at some point. And I'm sure you guys did one before I joined as well. But really happy to be doing one of these again, and we're more than likely going to be doing these roughly every month at the very least, just so you guys have a better understanding of what's going on, as they say, under the hood, and so you can speak, to the devs who make all the magic happen. Some of them, since there are a lot of devs on Arbitrum now. But before we get into the actual, the announcements and other stuff that we want to talk about, we can probably start off with intros. I will be the moderator for today's office hour session. I'll definitely do my best because probably half the stuff is going to sound like, hieroglyphics to me, but it's fine. I'm also the community manager here at Offchain Labs / Arbitrum. If you want, Fred, you can kind of start off. Like intro yourself and whatnot.
Maybe I'll pop in instead then, while we wait for Fred.
Sorry, I'm having a couple of network issues. I'm jumping into my phone. Give me a second.
Yeah, Kristen, you can go ahead.
Okay, yeah. I'm Chris. I work on the application engineering team. So we're kind of responsible for making sure that developers can interact well with Arbitrum. And also we're responsible for building the user interfaces like the bridge and things like that. So we're kind of the team that works in between the core Arbitrum node and the rest of the world. Yeah, maybe next person, Dragisha, maybe?
Sure, thank you. Yeah, so I'm Dragisha. I also work on the application engineering team, mostly focus on the user interfaces side of things. Yeah, and I'm a big fan of Chris's work on the SDK. I'm the main user, basically.
Hi, I'm Harry N. I also work with the application engineering team. I usually work with the integration with Teams and also work with the Token Bridge stuff, smart contract, etc. Yeah. Bring you up. Yeah.
I'll go ahead. Hello, my name is Daniel. I'm also on the application engineering team. We all are. I do a mix of kind of software engineering and documentation, technical research, that sort of thing. Fred, if you're there. I think you're there. I see you unmuted.
Oh.
We do not hear you, Fred.
Okay, we can't hear you. Have you ever had someone intro someone else?
I think they've ever done that. It feels a little presumptuous. Fred's, he's like us. He's another one.
You're right. Well, let's give him like a couple seconds. If not, we can jump in and maybe he can kind of fill us in on what he does. Yeah, no, Fred, we can't hear you. Yeah, probably just like a network issue or something. It looks like he'll just be rejoining us. But yeah, I mean, I guess just to go over like a brief, just to give you guys an idea of what we're going to be talking about today. We kind of going over some dev-related announcements, some stuff going on behind the scenes, and obviously, you guys in the chat, if you have any questions as we go along, we can kind of stop, midway through each section to kind of answer some of those, assuming that they're kind of related to dev stuff, and then in general, we'll try to make it as interactive as possible, but also as informative as possible too. Looks like we have Fred back. Fred,
can you hear me now?
Yes, we can hear you.
Nice. Hey, I'm Fred. I'm also part of the integration engineering team, and my internet many times doesn't cooperate with what I want to use it for. But yeah, a bit all over the place, doing Token Bridge stuff, UI stuff, SDK stuff. Yeah, and looking forward to this office hour sesh.
All right, awesome. So now we get the intros out the way. I think we wanted to start off with some announcements related to development going on over here. So Chris, if you could kind of kick that off for us with some of that SDK related stuff, whatever that means.
Yeah, that's right. So actually, I've got a couple of slides, but I can't share them really here on the Discord, but I'll just drop them a link to them in the chat so people can follow along if they want to. Yeah. So basically, yeah, I want to talk about the Arbitrum SDK and what it is and where it's come from, and its relationship to Nitro and what we're going to be doing around migrating the Arbitrum SDK users during Nitro. So it sort of came out of a library we had called ArbTS, which was for interacting with, mostly for doing deposits and withdrawals from and to the Arbitrum chain from Ethereum. And it was quite bulky to use, and we wanted to break it down and make it more modular, more intuitive, and also start adding more features to it. So we decided to kind of like do a bit of a restart there, and we've ported all the functionality from that into a new project called Arbitrum SDK. And it's completely breaking in changes, so we thought this was a good time to start afresh there. Yeah, it's a TypeScript library. It handles all the deposits and withdrawals to and from Arbitrum, as well as provides tools for making, creating, and inspecting the underlying messages that are going to and from Arbitrum and the states that they're in and executing things based on those. It's also got tools for force inclusion. So that's if the sequencer is down and you can't get your transaction in through the sequencer, there is another way to get your transactions into Arbitrum, and that's by pushing them directly on chain, and then after a period of time, if the sequencer hasn't come back up, you can actually force those to be included into the chain. And so we provide tools for doing that via the SDK. There's also the ABIs for all the contracts that we have on Ethereum and the relevant precompiles and things like that on Arbitrum. And also Arbitrum exposes a slightly adjusted RPC. So we've got some deserialization functions for inspecting that new data and using it in nice ways. And there's also a bunch of other miscellaneous stuff. So what's going to happen with the upgrade to Nitro? So Nitro introduces a bunch of breaking changes that are going to affect the SDK. So first of all, we do need to have a new version of it to work with Nitro. The second thing is that we want a seamless upgrade. So we want to be able to upgrade from our classic stack now to the Nitro stack, and not have any, well, there will be some downtime, but not force people to upgrade a package right during that downtime. We want to be able to upgrade prior to that, and then that single package will be able to work all the way through. So there'll be 3 main versions of the SDK to think about. There's version 1, which is only works with the pre-Nitro version of Arbitrum. And then there's version 2 of the SDK, which is out now. That's the current version. And that's what we're recommending everybody upgrade to now so that they have a seamless upgrade experience. And that's going to work with both pre and post Nitro versions of Arbitrum. And then finally, sometime later in the future, when Nitro has settled, we will release a new version 3, which will be just Nitro, and we'll sort of get rid of a bit of technical debt in there, and we'll also start adding some new Nitro specific features into that package. Yeah, so just to go over the timeline again, SDK version 1 has been out already for a while, but only works pre-Nitro. SDK version 2 is out now, and we want everyone who's using the Arbitrum SDK to start using that as soon as possible. There may be some sort of patch releases in between now and the Nitro upgrade, but there won't be any major version bumps between them, no breaking changes. And so everyone should really get onto version 2 before the Nitro upgrade. If they're using Arbitrum SDK or RTS, they should get onto that. Then the Nitro upgrade will happen, and then at some point in the future we'll have version 3 released. That's pretty much all I wanted to talk about with the SDK migration.
Awesome. And I guess it's worth also mentioning that obviously we'd love input from everybody in the community, I guess majority devs in this case, on any of these updates going forward.
Yeah. So if you've got any questions about that process, or there's anything you want to know, then just drop a question in the chat or get back to us. If you drop something like during this AMA, then I'm sure we can also answer it right now as well. But yeah.
Awesome. Thanks, Chris. Yeah, as you mentioned, if you drop anything in the chat related to this, we'll definitely be happy to address it. But just in case, at least until we see anything like that, we could move on, I guess, to some of the stuff that we're doing behind the scenes. And it looks like Dragisha, if you want, you can kind of start off there.
Yeah, sure. Thank you. And yeah, Fred, if you ever want to jump in, feel free to. But one thing that we've been thinking about doing is, once we have, now that we have the new Arbitrum SDK, which makes developing stuff for Arbitrum much easier, we also want to build another abstraction on top of that called the Token Bridge Sdk, which will make it much easier to build user interfaces for bridges for user interfaces for bridging assets to and from Arbitrum. And it's two main reasons why we want to do that. The first one is, we want to come up with nicer abstractions and make the code in our own code base easier to maintain and easier to reason about. And then the second point is to actually make it a lot easier for you guys to come up with your own, bridge interfaces for Arbitrum, in an effort, to basically decentralize the Token Bridge UI and not have the Arbitrum Bridge UI be the sole UI for that. Yeah. So if you guys, if any of you guys already tried building a UI for bridging to Arbitrum, and we've come with some issues, feel free to drop some comments in the chat, and if you have any ideas on how we might solve this issue together, yeah, just drop it in the chat.
Yeah, and I think something to just flag there, and this also goes as well with what Chris said earlier, is that we are really looking for input from you guys. So if you do have a really interesting idea or something novel, or even just in general a thought that you think is worth letting us know, we're really open to hearing you guys out. I think that's just the one thing that's really cool about crypto, is that you can, assuming your idea is cool enough or it makes sense enough, for the most part it'll easily be implemented, as long as it makes sense, to be clear. But yeah, definitely worth dropping an idea or a thought if you have any. All right,
Yeah,
I think we can move on to. Sorry, go for it.
I was going to say, we're also really keen to hear from developers using Arbitrum already, if they have any pain points or any problems or anything like that. Just a way for us to get feedback on that kind of stuff, or potential developers who've been trying to read the docs and trying to figure things out but having problems with it or anything. We're always looking to improve there.
Awesome. Well, I think we can continue to move on talking about the Token Bridge with Harry. Harry, are you there?
Yeah, I'm Harry. Yeah, sure. So we are going to have some new feature with our Token Bridge. For example, we are going to have a deposit and call feature soon. So that will allow that developer to have one-click bridge, and let's say RFA want to. I'm not saying they are implement this, but for example, they can have from L1 they can initiate one-click bridge and deposit to RFA in Arbitrum. So we are going to have this feature implemented in our Token Bridge soon, and that will give a much better user experience to the users. And if definitely you guys are interested to use this feature, definitely check out our repo soon. Also, we are going to have a custom refund feature soon. So this actually how I have to explain how the cross-chain message in Arbitrum usually works. So we have a mechanics called the Retriable Ticket. Usually, if you want to send a message from L1 to L2, you create a Retriable Ticket from L1, but you have to attach a gas because you have to pay for the gas in L2 execution and the storage. So usually, for example, a user want to use our bridge to bridge some, let's say, USDC to Arbitrum, they have to pay for the gas, and then they get it bridged to the L2. But usually, because the gas refund is actually usually get refund back to the calling contract, So there's be some problem with that they want to the gas refund get back to the user. So we are going to have a new entry point that allow devs to have be able to specify where they want the gas to be refunded to. So there will be a easier integration for all sort of other application. Daniel, do you want to talk about the new Token Bridge UI? Or Dragisa?
I can talk briefly. I feel like Dragisha maybe it makes more sense to talk about because he's definitely done more work on it. But basically, yeah, just another thing that it's the thing here is that we are gearing up towards releasing a new version of our bridge user interface, which will be very nice and have a lot of cool features. So yeah, Dragisha's been doing a lot of work on building that, and Val, who's not on this call, was behind designing it. And yeah, it looks great. It was generally look better. And be easier to use, and just have sort of a clear sense, the trickier UX problems, things like deposits and withdrawals, and giving a viewer a user rather, a sense of what's going on there. It will do a much better job at also exposing more of the kind of the different components of paying for gas. That'll be there within the user interface. So yeah, I think this will be a very positive thing. Yeah, I think that's all. If you want to add anything, Dragisha, feel free.
I think you covered it all. Thanks.
Great.
I mean, I could definitely just throw in there, to be practical here. That means that when you're going to the bridge page, once this revamp is done, like instead of doing like the average 7 to 8 day withdrawal, which people sometimes do and don't realize that it takes that long to actually go from L2 to L1, you'll be prompted more than likely to be using an alternative bridge so that you don't kind of get yourself in a situation where it's like, okay, I want to withdraw back to layer 1, but I'm afraid of the time it takes to withdraw. So you'll be more aware of the decisions the options that you have when you're actually withdrawing ETH from Arbitrum. If you choose to do that, which you probably shouldn't.
That is an important thing. Yeah, we'll make it easier to find the fast exit bridges, which is probably the most important thing actually. So yes, also it will look different, so don't panic. Everything's going to be fine. But yeah.
Yeah, if you do panic, then just message us in the support channel. We'll help you out, all right?
We'll let you know before we release it, obviously.
Awesome. Okay. Well, I think we can then move on to a little bit of the questions that some of you guys had actually asked us in the Dev AMA questions channel earlier this week. It looks like we can get started with one of the first thing, which is what is gas in Classic and Nitro? Arbitrum Classic and Arbitrum Nitro. How is it different? Yeah, go ahead.
Fred, are you? I was going to say, Fred, if you want to start and see if it works, we can try it. Or are you just technically?
Yeah. Can you hear me?
Yes. I'll step in if you cut out. Yeah.
Sweet. Yeah. Let me know if I start cutting out, and then someone else can take the mic. But yeah, a question we get very frequently that is always interesting to talk about is what is gas? And I guess this question also holds for Ethereum, right? And going into Arbitrum, it gets there are more things you need to take into account to understand what's going on when we're talking about gas. But maybe like a quick intro to just contextualize this would be that gas is the unit for metering the resources you use on a blockchain, right? You have some computation going down on a smart contract. You have some storage you're doing. All these are resources you're using from the network, right? So all nodes that are keeping up with the blockchain are also doing. They're imposed a cost for each of these actions you do, and gas is just the units that you use to keep track of that. Ethereum has this gas system, right? That many people try to gas scope on, try to reduce these costs so that their users, when they're making transactions to interact with stuff, it's cheaper for their users. And in Nitro, it's no different. Sorry, in Arbitrum, it's no different. I think what is particularly interesting to talk about here is what are the things you should be aware of when interacting with gas in Arbitrum, and what are the things that are going to change from Arbitrum, from the current state of Arbitrum and after the Nitro upgrade on Arbitrum. And maybe let's start with the Nitro part, which is the more interesting and the cool part. And the TLDR there is pretty much With Nitro, the way we charge for gas on the L2 is going to be the same as Ethereum, pretty much. No changes there. There's going to be just one extra layer, which is whenever you're interacting with a rollup, there's a cost you're incurring, which isn't expected with just regular Ethereum, right? When you're doing regular Ethereum, you get charged for storage, for computation, all those things, but they don't have this idea of the security budgets, right? That is, when you're interacting with the rollup, the call data of your transaction is all posted to Ethereum, and that's an extra cost to the network, which isn't present. It isn't present on regular Ethereum, so that's something we need to add on top of it. And the really cool thing about Nitro is all the execution and storage costs, things going on the L2 side, they're metered in terms of gas costs the same way as Ethereum. And one of the reasons for that is because with the Nitro upgrade, we actually are going to run Go Ethereum on the L2. So we get all the gas accounting and all the gas rules that are used by Geth itself. But then we have a small change on top of Geth, in which we add this notion of how can we calculate and charge for the cost that your transaction incurred in terms of L1 call data. And that becomes the only difference. The way we make this work is we see how much call data there is there. We see how compressible your call data is, and we make this estimate of like your transaction. If we were compressed using our compression algorithm, how much would it cost to actually post that on Ethereum L1? And then we just convert the number into L2 gas itself. So your gas limit still encompasses the L2 gas and L1 gas in a consistent way that you sign on top of the transaction, and you get charged for that. And it's a pretty neat system. I guess that's already a big information dump. I'm curious to see if people are saying anything on the chats. But yeah, I'd say that's the biggest thing on Nitro. On Arbitrum, on the current state, it's a bit different. Sorry, go on, Daniel.
No. Oh yeah, go ahead.
Yeah, I was going to say that in the current state of Arbitrum, it's a bit different the way we calculate these gas costs for L2, like computation, storage, and these things, because we have our own custom like VM and our own custom node. So the way these gets metered and accounted for is based on this implementation itself. So with the Nitro upgrade, we're scrapping that and being even more compatible with Ethereum by using Geth and all the gas accounting from there.
Yeah, there's just another little change. I won't go into the details, but just to sort of maybe intrigue the some people. In terms of the Fred was talking about the L1 component of a transaction. The user has to pay for the L1 call data, and essentially they're paying the sequencer, right? The sequencer posts these transactions in a batch, so they initially incur the costs of this call data, and then part of your fee is covering that. There is this kind of tricky problem there where basically if you, the sequencer doesn't quite know how much to charge initially, right? Because you give a transaction receipt right away and then you post a batch sometime in the future, and the sequencer can't predict the future because infant fees could go up. So in the current system, it's a little bit hand wavy, and we sort of say, okay, depending on how fees spike, there could be temporary, periods where the sequencer is slightly operating at a loss. If, suddenly fees go up because, whatever, Bored Ape team's doing another whatever sale. But in the new Nitro system, we're actually have a nice way of improving on that, where we can sort of nicely guarantee that the sequencer just breaks even on that cost, and the cost there, any sort of surplus in fees, kind of gets nicely amortized among the system. And if the sequencer is underpaid, it'll get compensated. I haven't explained how that works, but you can, yeah.
There's one thing to add there as well. That is on the current system, it still does get like compensated over time. There's an adjustment factor that goes adjusted over time, but just on the Nitro system, just works much more neatly and faster way. And just
you're breaking up a bit, but yes, you're right. Basically, in the current system, I said it was hand wavy. It's still it's not completely hand wavy, but the new system is sort of a nicer, more elegant design that we'll probably write up about soon. Yeah.
Awesome. Well, I think then we can move on to the next queue, which was does Arbitrum support EVMOS? I don't know if I said that correctly, but
yeah, I've heard it said EVMOS. I think that was a team member I heard it say that, so I'll call it EVMOS. Yeah, so it's sort of this is a little bit of a seen this question in a few places. It's a little bit of a strange question in that it's sort of it depends what you mean, but basically, you can think of Evmos and Arbitrum are similar in some ways in that both are these like EVM compatible execution environments. The whole design of Arbitrum is that it's an EVM compatible execution environment that derives its security from Ethereum itself and can sort of settle back on Ethereum, that kind of thing. In principle, you could, so in the current state of Arbitrum, we have a single Arbitrum chain, Arbitrum 1, that runs on top of Ethereum in terms of a single mainnet chain anyway. And as of now, the sort of vision down the line is that, there'll be multiple chains, it'll be easy to launch your own chain, that sort of thing. We don't encourage that yet because we're still in beta, but down the line in that future world, in principle, you could run Arbitrum on top of any chain that is EVM compatible, right? So that's Arbitrum. Evmos is kind of, similarly an EVM compatible chain, but it's not designed, it doesn't sort of derive security from its base chain. It sort of has this loose coupling of security in the style of the Cosmos ecosystem, and it's really designed for this like compatibility of tooling with the IBC with the IBC protocol. But basically, since they're EVM compatible in principle, like I said, you could, for example, if this is what you mean by the question, you could down the line in principle launch an Arbitrum chain on top of an Evmos instance. You could do the opposite too. You could launch an Evmos chain on top of an Arbitrum instance if you want to, for some reason, for all I care. So the technologies are compatible in that sense, I guess. But as of now, Arbitrum's its own chain, and I believe there's a single Evmos chain that is its own chain too. I hope whoever asked that answers your question. I may have totally misunderstood what you had in mind, but yes. But the answer is yes. Arbitrum supports Evmos.
And I don't know if it's related in any way, but while we were actually at permissionless the other week, someone actually, the first person, the first person I ever had asked me a question about the Arbitrum instance on XDAI. I'm just like, people actually use that? I don't think so. And by the way, this is no endorsement for that at all, because we have no idea who did that. but if that's something similar, then I guess technically it's possible. But
that's as far as the tech is concerned. In principle, you can spin up an Arbitrum chain on top of anything that is EVM compatible. But you shouldn't do that yet.
All right, thank you, Daniel. Next cue we had was, and I saw someone actually asking this in the current chat, but how does the ETH merge impact Arbitrum? And I guess we can kind of, whoever wants to talk about this one. I'm not sure if Fred's mic is still messed up, but if it is, then
we'll do the
just
backup
cutting
thing.
off a bit. Can you hear me?
Yes, sounds good.
Sweet. My internet's just acting up like there are blips in which I can't hear anything. But jump in wherever you see fit as well, Daniel. But I know you have many interesting thoughts on this as well. But I'd say that immediately when people, I guess there are two things that maybe people sometimes conflate. There's the ETH merge and the ETH 2.0 roadmap in general, right? There are the different steps towards the different features that are being rolled out. But with the merge itself, what that means is Ethereum is dropping proof of work in favor of proof of stake. And that's one specific and very cool, very relevant part of ETH 2.0 that I bet many of us have been looking forward to for a long time. And with the switch to proof of stake, I guess there are a couple of things that might impact Arbitrum, but nothing that will pay dividends straight away, let's say. A cool thing that will happen is L1 block time will be slightly faster and more reliable instead of the proof of work one. There will also be better guarantees in terms of reorgs on the L1 because of the fork choice rule, which makes it easier to reason about finality. Maybe not easier, but it's not probabilistic finality anymore. It's the fork choice rule used by POS Casper, which is cool. And also, it's worth mentioning since it comes up many people actually mean ETH 2.0. And with ETH 2.0, there are many things further down the line which do directly benefit rollups such as Arbitrum quite a bit. When I say that, I mean, for example, data sharding, with proto-dank sharding and different proposals around that. That means that the L1 footprints, the cost of L1 data in a rollup will become much cheaper, which is really cool that our users will love and we will also love. Another thing which is interesting is because further down the line there are different things you can do and different things that a new design space is possible for, like when you're thinking about censorship resistance on the base layer, which is quite interesting for rollups.
Your sound was not cutting out. We heard all of that. Thank you, Fred.
Nice.
Yes. Thank you so much, Fred. All right, we can move to the next one. Definitely, probably more of a, I guess, a practical question for a lot of the users, probably in the chat actually. But if it takes a week to withdraw tokens, coins, whatever you want to call them, besides using third-party bridges, will official bridges be faster to withdraw in the future? And Daniel, I guess you can take that one.
Yeah, so there's I'll start with the, if I want to, I'll start with the like annoying pedantic answer, just because I feel like it. So currently, these fast bridges, like for example, Connext, you're able to sort of bypass the 1 week window for some small fee. In some sense, those bridges are applications built around the official bridge already. In other words, the reason Connext is able to exist. So if you're using Connext to withdraw some token like DAI, that representation of the token is the one that comes out of the official bridge, right? So it's because there is this slow-moving long-term guarantee that you'll be able to slowly settle is why liquidity providers can do this fast settlement. And that's basically true of any trustless bridge, essentially, is that it's sort of an application built on top of the official bridge. So that's the annoying answer is they already are. But I guess a more, maybe more to the point of the question, or a more interesting thing is, so in the current bridge contracts, they do have implemented, if you are exiting via the bridge, if you're withdrawing, that withdrawal is actually tradable. So on the way down to layer 1, you can transfer ownership of it. And essentially, what some developer or some team of developers could do, which no one's done yet, is you could build a fast exit system directly on top of that. You just need sort of some other logic, which kind of does this kind of swap logic, which says when you can get this liquidity as long as you're provided in this other place, that kind of thing. So I'm definitely all for somebody building that, and yeah, they could integrate directly into the contract. In terms of like the pros and cons of these different bridge designs, it's on a very, if you sort of squint your eyes and zoom out, in terms of the trustless bridges, they all work very similarly in that like there's some liquidity provision, and that lets you get a fast exit, and the liquidity provider gets a slow exit eventually. In terms of the pros and cons of the details, it gets a bit dingy and wonky, but it has to do with how many actions are required by the user. And how much in fees is the user going to have to pay. How exactly the fee negotiation works is an interesting question. That's different in some of these. So what's the most efficient way? So yeah, this is kind of an interesting design space if you want to be like hyper focused on bridge design to figure out which of these versions is best. But yeah, the tradable exit version I don't think is quite something that is live. So yeah, that'd be a cool project. Maybe I'll just say one more thing. Maybe the simplest way to answer this question, maybe this is what they meant, is they just want more direct access to fast withdrawals in the sort of bridge interface that we offer, if that's what you mean by the official bridge. And then, yeah, like Hunter said, V3 of the bridge will expose that stuff more directly. So you won't have to go hunting for a third-party bridge to give you your fast withdrawal. You can just like choose something right in the interface itself. So that'll be good.
Yeah, for sure. And I think it's really exciting, like the moment where people start using like the tradable exits on top of the main canonical bridge, because you can build so many different things on top of that, because it seems like a pretty simple primitive, but it's really powerful in terms of what you can do with it, especially when you compose that together with smart contracts that it gets traded to, and then that triggering functionality eventually. And you can do like all sorts of like counterfactual systems or eventual consistency kind of things, where like if you're examining both chains, some off-chain states, you can build a lot of fancy stuff.
Yeah, you can do weird, like, you can wrap it in various DeFi protocols. You can do like futures of the token, as it eventually arrives, that kind of thing. Yeah, so it gets it's fun. That's it. Yeah, and that is one of the cool things about the tradable exit design, is it's more sort of leaves more room for these cool cross-chain DeFi games.
Exactly. And like the 7-day delay, like the delay on L2 to L1 transactions is somewhat fundamental to like optimistic rollup protocols.
Yes. So yeah, fundamentally there has to be a delay kind of somewhere, right? If you want to move assets, somebody's gonna have back to layer one. Someone's gonna have to wait at some point, right? So these fast exit schemes are for fungible assets, and it's for a sort of liquidity provider who's willing to sort of accept that time value in exchange for a fee.
I'd argue that these systems are even for like non-fungible things, because the interesting thing is this delay is only for the L1 itself. Like the only
You're cutting out, so I get to get the last word in. So it's tricky. We've had this debate. I think there's in some sense you could do this with non-fungible things. What you could do is before the 7-day window, you could sort of have a token, an NFT, for example, that represents rights to the withdrawal that's in flight, and you could and that itself is guaranteed, right? But you can't quite move the actual non-fungible thing itself until 7 days. So it really depends, whether that's good enough. Depends what you want to do with it, right? If you just want to sort of own this thing so that you can trade it, then yeah, you can actually get that. If you want to like withdraw an NFT, get it to layer one, and then trade it such that the person who receives it just has a guarantee that they'll get the NFT itself eventually. You can bypass that. You can bypass the 7-day window there, which is another cool design space that's kind of lightly explored still. So
exactly, and that's why tradable exits are so powerful, because it allows you being off chain to act on top of this state is going to happen, and just progressing the L1 states based on that. Because just the L1 is the one with the delay, so everything that is off chain can know what's going to happen based on all these things. So many times you can design around all these things, which is really cool.
Yes. Agreed. Thought we were gonna start arguing, but I guess we agree. Okay,
Awesome,
we can
awesome.
move on.
Yeah. Yeah. I mean, I'm sure we could talk about bridging, especially NFT bridging, like all day. I think our last dev office hours was actually about that NFT bridging. But yeah. So the next queue is coming. Okay, it's about ETH call data and compression. So besides compressing ETH call data, what are the ways to reduce gas fees in the future on Arbitrum? And looks like Fred, you can take that one.
Yeah, I'm happy to. Yeah, we've been talking a lot, but yeah, so if anyone wants to jump in, feel free. But yeah, Fred, if you want to get started.
Sure. The idea is kind of like what we alluded to earlier, right? That is, we charge not only for the call data itself that your transaction creates that needs to be posted on the L1, but now we actually have this idea of the protocol compressing this data in the batch. So what we charge for is actually how compressible the data of your transaction is. So a cool example to think about this is that if you want to like reduce the gas fee, and you're doing a transfer to someone of, for example, 1 ETH. When you're transferring 1 ETH to someone, what that gets represented in call data, it gets represented in hex. So 1 ETH in hex is something like 0xDE0B6B3A7640000. And that's just like, it has a lot of entropy on this. It's not a very compressible number. So instead of sending the number, you decide to send like 0.936748 or ETH. When you change that to hex, the hex, well, it actually gets posted in like bits, right? But I mean, hex is just to give a clear representation. Then it gets posted as 0xD0000000, which is a much more compressible value in the call data itself. And if you extend this to like many of the parameters you're using on your contracts, it's something that you're able to reduce costs quite a bit, because your whole transaction call data is not that you only post less call data, but you also post this smaller amount of call data in a way that it's more highly compressible.
Yeah. So basically, like, there's two things. There's we'll sort of get call data compression on the protocol level with Nitro. That'll just happen. And then it's kind of an interesting little challenge there is figuring out the amount that you charge. Because like Fred said, you have to charge for how compressible your transaction is, which is always going to be an estimate, right? Because you don't actually, there's no objective way to know how much savings you're gonna get, compression savings you're gonna get from an individual transaction until you have the whole batch and post it. So the sequencer uses this heuristic and charges you for like how compressible it looks. So that's cool. Yeah, so you can optimize for that. And then also you can just directly optimize in your smart contracts by minimizing the amount of call data. that your contract calls use. And that's the we actually have somewhere tucked away in our library. You can you can write your contract so that instead of taking in a bunch of individual parameters of all these different data types, you can just take in like one big byte array and then parse that out and parse each of the what would be individual parameters. So that's like we did that in our testnet for the Uniswap contracts. We did that just as a demonstration of just minimizing call data at all costs, because that's the most expensive part. The other thing I'll just flag is we have a precompile called the address table, where you can register. So this is if you're going to be reusing a given address for whatever reason as a parameter, let's say, instead of passing in the whole address as a parameter, you can register it, and then later you can kind of look it up. And you look it up by an integer, which uses less call data than an address. So that's definitely something that would be cool to see more teams use.
Yeah, for sure. And something that I haven't seen teams use yet that doesn't even rely on smart contract changes, just the front end changes that I mentioned earlier, is with this call data compression. Like, what you can do is just use values that are more like repeated digits when you represent it on the low level. And that will be pretty effective and won't need smart contract changes, which I think will be something really cool to see once Nitro is live.
All right. Yeah, and I think an obvious topic here too is EIP 4844, but I think Fred had mentioned that actually earlier on in the AMA. So, if you're wondering, if you want to hear more about that, then we'll post the recording afterwards and you can listen to it again. I think the next cue we had was about cross-chain stuff. More specifically, on like the flow of cross-chain transactions, and I guess just how that works generally. Chris, you wanna take it away in this one?
Yeah, so cross-chain transactions, or like cross-chain messages as we call them, are quite complicated, and they're a source of a lot of confusion, and there's a lot to talk about with those. So I thought it would be good just to go over a very brief overview of what they are. We can dive into more detail if we want to, but just a kind of like a refresher reminder of like what's going on there, and a kind of high level overview of what's happening. So there's a general messaging framework that allows you to pass messages from L1 to L2 and L2 to L1. And all of the token bridges that we have, and everything that communicates between L1 and L2 uses this general messaging framework. And to show the Arbitrum SDK again, if you want to get good insight into what the messages are doing, then the Arbitrum SDK is a good way to inspect messages, to create messages, and to just deal with them in whatever way you want. So to talk about the Ethereum to Arbitrum messaging first, L1 to L2, we also call these deposits. So in this, you would specify you're on L1, but you want a transaction, something to run on L2. And you want it to be atomic, right? If you send transactions on L1 and they get locked on L1, tokens on L1 and they get locked on L1, you want them to be minted on L2. You want both sides to happen, because if one side fails and the other one doesn't, then you're in trouble. So the system we have for that is called Retriable Tickets. What you would do is use the Token Bridge contracts to create a general message, which is going to instruct the amount of tokens that are going to get minted on L2, and it's going to lock up the same amount of tokens on L1. That message gets read by the Arbitrum node, which will create a retriable ticket for that message. And the retriable ticket exists. The reason why we don't just execute it straight away is because the address that would want to execute that on L2 may not have L2 ETH, or there may be some other complication with the transaction that causes it to fail on L2. So we want to provide a way in which this ticket can be re-executed to make sure that it happens, to preserve that atomic property that we're looking for. We create this retriable ticket, and then Arbitrum has a go at actually executing it the first time. So you get kind of like one go for free with Arbitrum. If that fails, then the ticket stays there, it doesn't get removed, and anyone can come along for the next week. We usually keep the tickets around for and have a go at executing that ticket to complete the L2 side of that. And you can also actually extend that lifetime. So if for some reason you don't want to execute that ticket now, but you want to execute it in the future, you can extend the lifetime to execute it later. Yeah, so the basic flow is, again, like you send an L1 transaction, it creates a message that gets read by the Arbitrum node, which creates a retriable ticket. It then tries to execute that retriable ticket once. If it fails, then that retriable ticket needs to be manually redeemed by a user on L2. That's kind of the way that L1 to L2 messaging works. And then L2 to L1 messaging, this is where the fraud proofs come in. So to send a message from L2 to L1, you send a message to a specific contract on L2 called ArbSys, and that will then be made available on L1 after the fraud proof period has elapsed. So there's this fraud proof period where anyone can challenge the state, and they can challenge whether or not that withdrawal that they can see about to happen is actually valid according to the state that's happened on L2. So that takes about a week. And with going from L2 to L1, there's no Arbitrum doesn't try to execute your transaction for you when it arrives on L1. It's always manual on L1. So that's one difference between going from Ethereum to Arbitrum and Arbitrum to Ethereum, is that you always need this two-step process. The user always needs to initiate it on L2, and then they always need to complete it on L1 1 week later. Which is why it's kind of nice to use things like fast bridges, because they do all of that kind of stuff under the hood for you, and they instead give you this fast option, which they do for you. Yeah. So that's kind of like a brief overview. I don't know if you want to talk any more, Daniel, on that.
No, I think that's a nice overview. Leave it there.
Awesome. And I guess a good segue for that would be kicking it off to Harry. The Q is how to test L1/L2 cross-chain messaging and whatnot effectively with hard hat. I don't know if you're there, Harry.
Yeah, just a sec. I'm sharing a PR in the AMA chat channel. So actually, we have some tests. We have a test helper in our Token Bridge, the Token Bridge develop branch in the GitHub. So you can actually, I don't know how to. Yeah. So you can actually simulate L1 to L2 end-to-end test by have some mock contract. Actually, we use the hard hat impersonate in between. So we have a mock contract that capture the L1 to L2 message, and then we have a helper function that's help you to like impersonate the L2 call, so that you can experiment with the L1 to L2 cross-chain messaging without actually have the L1 to L2 set up locally. But if this is for the pre-nitro Arbitrum, but if you want to if you are working on Nitro, you can also set up your own L1 and L2 Nitro with our Nitro repo. So in that case, you can actually have a local Nitro setup there to help you test the cross-chain messaging. Let me see what they are asking. Yeah, so I think that's pretty much it. But
One thing I'd add there, are you able to hear me? I always need to mic check.
You're good. You're good.
Sweet. One thing that is cool about the hard hat setup itself is that you can use all the hard hat debugging tools as you're doing developments, right? For example, the console.log functionality, just the stack traces and all that. That when you run a local node, what happens is that you're running Geth and the network clients, the same stuff as on mainnet, so you don't get all the debugging facilities that you usually do on a local environment. And if you check out the PR, if you for the YouTube video later on, if you want to search it, if you go to github.com/offchainlabs/Arbitrum, that's the Arbitrum monorepo, It's pull request number 2218. And yeah, over there we have an example where we actually set the precompiled contract codes so that you can mock it, and the inbox also mocked. And it just allows you to do all this cross-chain stuff in a consistent way as you would expect in a live environment, but still having all the debug facilities for hard hat. And yeah, also like if people can reach out on Discord and through other means, and we can help you people get set up with it.
Dope. So I think that's what we mainly had on the agenda today to kind of go over. I don't know if you guys wanted to bring any kind of last points up, or any last topics about the tech that you guys are building. Just in case, I'll pause real quick, just in case you guys do have anything you want to kind of bring up. No? All right. I think we should be good then. Obviously, for everybody in the chat, we really appreciate you tuning in. The plan, as I mentioned earlier, is to do these roughly every month. So, if you have any questions or like any even thoughts maybe about like how we should even like kind of be structuring these calls, if you think that there's something that we missed that we should add, or vice versa that we should maybe take out, whatever it is, feel free to let us know in the dev category. In Discord, the dev chat category, actually. So that'll be kind of, if you scroll down on the chat there. Another note too, we mention this every call, but we're hiring for literally everything as far as I'm concerned, devs especially as well. So literally, if you are, if you have an addiction for coding and building really, really cool stuff, then this is the place for you. I'm sure these guys can contest to that. All right, guys. Can you hear me?
Yes.
All right, there you go. So I'm gonna get from the closing notes. Thank you guys for joining. We really appreciate y'all. And see you in the next one, all right?
Yeah. Thanks all. See you guys next time.
How are you doing,
Thanks,
y'all?
everyone.
Thanks.
Thanks,
well.
bye.
But